Hi everyone. So in this video I want to discuss the different types of assignments that there are in Verilog, and that's because in the previous video we actually saw a peculiar kind of assignment which was using the assign keyword instead of just an equal to. So here I've created my test bench module and I have 3 registers right here and I have my initial block. So one thing that I can do is I can say a comma c equals 0 like this, and both a and c will be assigned the value of 0. These are just some default values that I'm giving, so I'll give b a default value of 1, and then let's add a delay of 10 time units, and then here I'll do my assignments, and then after a delay of another 10 time units I'll do my display. So I'll just print out all of my registers. So let's do a display A, B and C right here. So the first kind of assignment is just using the equal to. So let's say I do B equals A and then I do C equals A. Actually let's do an A equals B first and then we do a C equals A. So let's go through it once. A is 0 initially but B is 1, so a value of 1 is going to be assigned to A, and a value that is in A which is now 1 is going to be assigned to C now. So at the end of this, when I have the display, all 3 variables of mine should have the value 1. So let's go ahead and run this thing. So as you can see, I got all my 1s, which is fine. So one point here about this equal to, this is called the blocking assignment, and the reason the term blocking is used here because according to this assignment statement, while this assignment is going on, it won't move to the next statement that it has, and this is actually contrary to the next assignment that we are going to see, which is using the less than equal to. Yes, there is also an assignment statement in Verilog. So let's take a look at this now, where I do where I assign B to A using this assignment operator, and this is actually called the non-blocking one. So let's take a look at the output first and then we can see how we got there. So as you can see, I have a 1, 1 and 0 here. So why did I have a 1, 1 and 0? So my B has a value of 1 that is assigned to A. So A does become 1, but this assignment statement does not block the next statement from happening, which is setting the value of A to C. So A is originally 0. That's the value that's going to be going to go into C now. And A then gets the value of 1. So when I actually print it, I have 1 in my A which comes from B. I have 1 in my B because I didn't change B at all from here. And I have a 0 in my C which came from the original value of A that I had, which was 0. So that's the second kind of assignment using this less than equal to operator. So these are the 2 kinds of assignments, and remember that both of these have to be within the initial block or an always block. So let's take a look at the third kind of assignment, which can actually be outside of my initial begin as well. So let's get rid of this first, and let's get rid of that as well. So the third one is using the assign keyword. So I do assign B equals A. So let's do that, and here let's actually just try this out, and here actually after a time delay of 10, let's set A to the value of 1, and let's go ahead and try it now. And it says register B cannot be driven by primitives or continuous assignment. So the reason this is giving me an error is because this is called a continuous assignment, and for this my left hand side needs to be a wire. So let's make B a wire here, and let's try it now. So remember that I did an assignment here where even my A was not assigned, and then I'm assigning a 0 to A, and then I'm assigning a 1 to A. Actually, let's have a display B here as well, and let's go ahead and run this now, and let's do Bbb assignments.vvb. Now as you can see, the first value, which is of B, that I'm getting from line 16 right here is 0. Then I'm getting the value of A, which was set right here in line 17, that comes out to be 1. Then I have the value of B now, which is now surprisingly 1. So, and I have the value of C, which is 0 because of the initial assignment itself. So even though I just did an assign right here, my value of B here was 0, and then the value here was 1. And the reason that happens is because this is called a continuous assignment. So what this continuous assignment says, what this assign keyword says, is that whenever my right hand side of the equal to sign changes, I'm going to do this assignment again. So what I can do is I can also have an AND C here, and then in that case, if A or C changes, this assignment statement is going to be executed again and B is going to get a new value. So this is called the continuous assignment, and that's the one that we used in our NOT gate in the previous video. So this is about the different assignments in Verilog. I hope this video makes all these 3 types of assignments clear, and I'll see you next time.